Yep. Thank you.
Sure.
How are you, Romke?
How are you?
Yeah.
It's a long 4-day break.
Yes. Yesterday, I don't know what happened. I woke up a little late and then I couldn't make it. So, did you wait for me yesterday?
Yeah, we were waiting for like 20 minutes and then we left. Yeah.
Okay. Yeah. Anyway. Yeah. So, can you see my screen?
Yeah.
So we were here, I guess, the consolidation order. We
Right.
finished this consolidation order.
Right.
So I was going through this whole document
Okay.
and I found a few topics which were to be discussed, but
Mm-hmm.
we will still discuss them in our next class. Okay.
Sure.
We'll continue the same which we were continuing today, and then there are a few topics which are left out.
Okay.
So we'll discuss that tomorrow.
Sure.
And tomorrow is what? Thursday. So Friday and Saturday,
Right.
we'll try to cover them all. And
Okay.
then we will start afresh on next week with a demonstration or basically a case study.
Like a lab, you
Okay.
mean? Like.
Yeah. No, I mean, the case study will go on the paper first. So you'll
Okay.
have the weekend for you to spend on that case study and
Sure.
then come up with whatever you can.
Sure.
And Monday we will go practicals.
Okay. Sure.
Okay. Okay, so this symbol, the member 5, this is a modulus symbol.
Mm-hmm.
It's not a percentage. What this basically means is, so the division gets you the quotient value, right?
Mm-hmm.
But this
Yep.
modulus gets you the remainder value.
Okay.
Yeah, so if you use 5 modulus 4, the result is 1.
Okay.
Not, hey, it's the same, right? 1 and 1, the quotient and the remainder.
Right.
But basically, this is the remainder, not the quotient.
Okay.
Okay, 7 modulus 3 is 1, not 2. Okay,
Okay.
so that's one of the operators which we didn't look at.
Okay.
Okay, so there are these design considerations which you need to follow. I think you should be aware of this, how the roll up happens basically. So when you're looking at the design of the outline, you should have a few things in your mind that will help you in designing the outlines. Now, there are two kinds. One is hierarchy calculation order. The other one is the formula calculation order.
Mm-hmm.
Okay. Now, in the first one, there is no member formula. So on the top it has net sales. Under that it has gross sales and discounts. Now for the gross sales, they've calculated units into the price. For the discounts, gross sales into discounts. They used this gross sales as a shared member, basically. So wow, okay, can you use it as a shared member? Yes, because it's in the same dimension.
Right, yeah.
So you can use it. That's why they used gross sales. It's a shared member. Okay, now here on the right hand side, they made it very simple. You know, they didn't go for the children under the gross sales. Yeah, they just had a member formula saying that units into list price.
Okay.
For the
And what
gross
is it
sales.
next to the list price? The within parentheses, like a what is that calculation symbol next to list price?
It's oh, I think you have difficulty in seeing it. Now visible? It's
Yeah, no,
it's
yeah, but I wanted to know what operation it performed.
it's product. It's product.
Oh, product. Okay.
Yeah, it's product. So what happens is it multiplies the units into list price and then it consolidates to gross sales.
No, I get that, but I'm referring to that symbol next to units, like the input drivers, the you know
The units or list price?
input drivers. See that that symbol next to input drivers.
No, where is it? Input drivers. This one, list price or units?
No, and the formula calculation.
Yeah.
Yeah, but wherever it says input drivers, right on the screen.
Input drivers. Oh, yeah. Okay.
What is that sign next to that?
This is basically a cap, right? We talked about it. This tilde is ignore, and this is never share.
Oh, never share. Okay.
Yeah. I think. Let me take you back.
I know the tilde is like never share because, I'm sorry, the tilde is ignore because we have that in our hierarchy.
Yeah.
The other one was the one that I wasn't sure of.
It's a cap, actually. You call it as a cap.
Okay.
It's never share.
Okay, got it.
Where is it?
It was not on that.
Yeah, never consolidate.
Okay.
That means it will not consider.
Okay.
Okay. Is this what is the legible size? This one, is this good?
Maybe you can increase it a little bit.
Increase it? Okay.
Yeah, this is okay. Yeah, no, I see it. Yeah, okay, never mind. Never consolidate. Okay.
Yeah. Where were we? Okay, this is done. So, what do you think? Which one is a good one? Which one?
Between the hierarchy calculation order and the formula calculation order?
Yeah.
I'm thinking the formula calculation order because you're not creating all those trees and subtrees.
Yeah, so this is basically the smarter one, the formulaic calculation order.
Right.
Now, but if you look at the number of members, 1, 2, 3, 4, 5, 6, 7.
Right.
Right? Now here, 3 and 4, 7.
Right.
It doesn't change the number of members.
Okay.
Okay. What it does basically is when you are, how do I say? Um,
You can share it. Or are you saying if I have other parts of the tree where I can just define it once and share it anywhere I want, kind of?
no, I mean it works for both.
Okay.
You can share the members from here as well, right?
No, what I meant was, like, let's say you want units and list price somewhere down in the hierarchy. Again, you have to attach it to gross sales, right? Whereas here you can just, I mean, similar to, units and list price under gross sales. If you want to use it in a different subtree in the hierarchy, right? You need to again add it. Whereas in the formula calculation order, you can just call it, right? Something like that.
I mean it's a kind of when you're looking at the formulaic calculation order, these values, the input drivers. Okay, now these input drivers, if you look at the operators next to them, okay, so this is never consolidate, never consolidate. This one is ignore, and then never consolidate. But these values, I mean, there is no operation at all. Now, if you look at this, there are operations at every level.
Right.
This is going to take a longer time
Okay. Okay.
than this.
Right.
The operation happens only here. Here it takes the whole consolidation.
Mm-hmm.
Yeah.
Yeah.
So that's the difference. This is smarter way. I mean, you don't really need to, create members and then have a consolidation operator next to them to eventually get to have some value. Instead, you store them from the flat files or whatever it is, and then you have no operation on them because you hardly need them. All you need is you just use them as a reference and then use the member formula.
Right. Right.
That's all.
Yep. Hello? Did I lose you, Mohammed? Hello?
Hello, Ramki, can you hear me?
I just lost you for a minute.
Yeah, actually, power cut.
Okay.
So I lost my connection. I'm using my mobile phone now,
Okay.
personal hotspot. So okay, so that's one of the ways.
Okay. think I lost you again.
No.
Okay, sorry. I mean, your microphone, your mic symbol went like grayed out. That's why I wasn't sure.
I muted it.
Oh,
So
okay.
I was quickly going through these points. So, oh my God, where did I lose it? Okay, here. Okay, performance. Now let's go through this a little quickly. Okay. Uh, okay, although in many cases consolidation operators and the member formulas produce the same calculated data, you should maximize the use of hierarchy-based calculations and consolidation operators when building your accounts dimension. Okay, the main reasons for this choice are performance and visibility. The use of hierarchy-based calculations. That means he appreciates using this trend over this trend
Okay.
in accounts dimension. So let's see why. Okay, performance. When an outline is consolidated, hierarchy-based calculations are much faster than member formulae. For examples on the slide, there units and the list price are children of gross sales with consolidation operators. Okay, provides faster performance than the formula consolidation design, where gross sales is assigned as a number. Okay, visibility. Okay, so the performance is higher. How is that possible? Let's see. Visibility, hierarchy-based calculations provide. Yeah, visibility is one big advantage. You know, when you look at this tree, it's clearly understandable. You know, you don't need someone smarter to understand this over this. This is very simple. It's just that it has a gross sales, it has units, list price, discounts, gross sales, discount percentage. So anyone who's looking at this hierarchy will be able to understand what you're doing here. But I personally think, I don't know if the performance is high on the hierarchy ones over formulae. I prefer this formula calculation order.
Mm-hmm.
I personally prefer this. The reason is simple. You have the logic here.
Mm-hmm.
Yeah, the logic will. I mean, this one is a very, how do I say? When you're implementing some logic here on the formula calculation order, you know how you're using these members,
Mm-hmm.
the input drivers. You know how you're using them. You will try to understand the dependency of these input drivers. Do you really want to have them as ignore or a never share? Do you ever share these values anywhere in the accounts dimension? If you I mean, when you are looking at your whole outline, you basically try to understand, do you really need a consolidation operator against your member?
Mm-hmm.
And then you will try to understand, if I'm using this consolidation operator, is this member going to be a shared member? I mean, this is how you basically analyze a member. First thing, you try and find out what is the consolidation operator you're going to use, and then the next thing is share or never share. I mean, is this member there? Is there on the Excel sheet or whatever you're analyzing,
Mhm.
do you try to understand this column, the value of this column, is it being used somewhere else in the formulae, in the Excel sheet? Now, yes, if it is being used, then you'll understand, okay, this is a shade value. So you better mark it as a shade member. And then you will, so that's how you analyze an Excel report.
Mhm.
During the process of analysis, when you have the whole data with you, before you start your SBase, okay, you have all the sorts of data with you, okay, and then let's say you are looking at the accounts, the related Excel sheet, you go column by column, okay,
Mhm.
and then you try to look at the numbers. I mean, this is the dense dimension, right?
Mhm.
You don't really have to look at all the other columns in the whole sheet.
Mhm.
Numbers, because dense is numbers. So you go hit the numbers, the columns, wherever you see the numbers, and then you try to understand if you really need this column on the dimension, what is the importance of this column, where does it go in the outline, and then you will build the whole tree, the whole hierarchy. Once you build the whole hierarchy, then you will try and understand what is the consolidation which is going to happen at this member. Is it plus? Is it minus? Is it a product? Is it a modulus? Is it a division? Whatsoever. Now, once you're done with that, then there is something to understand. Do I need to mark any of these members as a shared member? Do I need to mark any of these members as ignore? Do, do, do I need to, why is this input driver ignore? I mean, the units ignore and this one is never consolidate. And the whole idea is simple. You don't need these values to be added to the parent. I mean,
Mhm.
you're just using them. You're just using them.
Right.
And in fact, when you look at the Excel sheet, you don't really need these units on the Excel sheet, right? When you're looking at having the gross sales, you just, you have your list price, whatever the CP is, and then you multiply it with units, and then you get the gross sales. Simple. Now, when I look at these columns individually, what is units? Is it going to be a shade value? No. Does it need to be added to any of the siblings and then get it consolidated to a parent? It doesn't make sense. Now, think about it. Units. Why do you want to consolidate that value? And if you have to consolidate the values, okay, so if I want to consolidate the units, there's one purpose: to understand the whole number of units.
Mhm.
Yeah.
Right.
That's one of the reasons it could be if I want to consolidate. If the requirement is they want to know the whole units sold, right? Total number of units sold
Right.
for a particular product. So that makes sense. But here, just to get the value of gross sales, it doesn't make sense. That's why they used it as ignore and then never share, never consolidate.
Mhm.
I mean, if I'm inclined toward this. However, Oracle has a complete different suggestion. They want this to happen.
Right.
And they claim that this is faster. I thought this one was faster.
Right. Right. Right.
Yeah. The reason why they could claim it's faster, it's because you're not I mean, the control is not shifted in the hierarchy. The control doesn't go anywhere. It doesn't have to look at some block to fetch the values, right? It's right there and there. You know, you just have consolidation. That's what I think. Probably that could be the reason. Okay, so when you, so these other things very important, very important. I mean, if that's what I told, right? The developer, two different developers can have two different ways to deal with it. If I was looking at this development of creating the developer outline, I would have gone for this. That's how I work. That's my style. I think I have to change it. This one, this one probably is someone who is not really into coding and all that stuff. Someone who's into coding goes into this sort of hierarchy. Someone who's not into coding, who understands, okay, all I need is, you know, consolidation operators. I can do this, I can do that. I mean, a basic, simple examination gives you this result.
Okay.
Don't think too much is this result.
Yeah, I mean, personally, my choice is the first hierarchy looks a little more logical to my mind. That way I don't have to get, I can just.
Absolutely. I mean, yeah, someone who is, okay, well, he wants it simple. He wants it designed in a very simplest way so that, you know, someone looking at that hierarchy should understand, okay, how you're calculating the gross sales. It's simple. Now this one, someone looking at this one has to, okay, so there is an input driver parent. Okay, what is it? It has units, list price, discount. Okay, so you're treating that as a different different level, basically. Yeah.
Yep.
Okay, so yeah, that's a good learning. This is good. I mean, you need to understand the difference. Visibility, yes, the plus point. I mean, overall, the 3 good points go to the hierarchy calculation order.
Okay.
Okay, so that's recommended. The following is the best practice design philosophy for building an account dimension. Whenever possible, use hierarchy relationships and consolidation operators for outline calculations. So they don't want you to use member formula. Yeah. When you cannot achieve your desired calculation with calculation operators, use an outline member formula or create a calculation script. For example, you may need to use a member formula for an account that calculates commissions based on several distinct conditions. Yeah. So this is what you cannot achieve using the consolidation operators against the members. That's when you will have to write the formula or the calculation script.
Okay.
Yeah. When you have different scenarios to be applied, that's when you cannot use the consolidations. When you want to eliminate confusion in reports by simplifying hierarchy paths, do not apply guidelines 1 and 2, even though the calculation for gross margin involves gross margin and net sales. Okay, your users may not need to see the detail. We need the gross margin percentage value. Yeah, what he's trying to say is do not when you want to look at the gross margin percentage, which involves the gross margin and the net sales, you know. So if you so basically You do not want this on the outline.
Mm-hmm.
Yeah. Although it's something which you want to look at, where the accountant wants to look at.
Mm-hmm.
I mean, you cannot put this in the hierarchy here.
Right.
In both, actually. Why in both is adding another member,
Mm-hmm.
which could be the what gross gross margin percentage. You'll have to add another member and then use the values between the gross margin and the net sales. You know, you basically gross, if you divide your gross sales with the net sales, that's when you will get the gross margin percentage. Now, for all these calculations, you don't really need to add another member again here.
Mm-hmm.
Okay, so that's what he's trying to explain. You can achieve that using the calculation scripts.
Okay.
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 I mean, not every operation you want to do, you make it available on the outline. That's what he's trying to explain. Okay, creating account hierarchies. Now, this is a good example, Gross margin analysis. So you have gross sales, you have discounts, and then you will have net sales. Yeah?
Yep.
So discounts are being removed or subtracted from the gross sales to achieve the net sales. So you will have discounts as minus, gross sales as plus, and then whatever the value is stored in the net sales. And the net sales again has a consolidation operator. That means the value of net sales is being added to the parent.
Right.
Yeah?
Yeah, I'm familiar with this. So we have a similar hierarchy. So the parent is MPG revenues or something like that. So.
Yeah. It's the same across all the accounts dimensions. It's the normal way the P&L works, the
Right.
profit and loss hierarchy works. Okay, these are the challengers. I think we should go through that. Okay, now testing, we'll go through that later, okay? I don't want to go into the practical part at the moment. Now this is the functionality, okay? Let me quickly switch, okay? Just give me 30 more seconds, okay?
You got power back?
Did I lose you?
No.
No, cool, okay. Now, how are you going to test your calculations, basically? I mean, this is not something which happens every time there is a load, every time you want to analyze the data. Okay, this is not what happens. But they have given you an example. Okay, how you need to work out, basically. Now, disable intelligent calculation. What do you think? How can you do that? Do you have any idea around that?
Disable. It's out of the box thing, right? Once you put these operators and all, how can you disable them, right?
So what I think I already discussed this once. However, let me explain it. I think this is the right moment to explain this, and it would be more effective. Essbase has a configuration file, okay, the CFG file, okay. Now, in this configuration file, there is an attribute, or there is an attribute. Yeah, attribute. When I say attribute, it's not the attribute with the Essbase, but it's
Property.
I mean, yeah, there is a property. It is to turn the intelligent calculation on or off.
Oh.
Okay. By default, it's already on.
Okay.
Okay. Now, when it is on, what it does is it basically performs a calc all. When I say calc all, the whole dimension is calculated.
Okay.
Okay. So whatever the consolidations operator you have, whatever the member formula, everything from the bottom to the top, whatever the data is available, it tries to calculate everything. Okay. Once that is done, once the calc all is done, it will mark every block as clean. That means the whole calculation is done.
Okay.
And let's say there is another load for a few combinations. Those ones become the dirty blocks.
Okay.
Now, Essbase is smart enough, okay? It will find out, okay, I have the dirty blocks now. It will calculate it again to make it clean.
Okay.
Okay, so this is the intelligent calculation. It will not calculate, I mean, it does it automatically. Okay, and you don't want this, okay? Basically, you don't want this because, I mean, you would have this on when how do I say, when you don't want to work, or basically when you don't when you want the whole database to be updated.
Right.
Okay.
Right.
You don't, I mean, if you want to work on a part of a database, or basically the slices, I mean, you're just adding the performance issues by having that on. So most of the times you turn them off. This option, you turn it off, and you basically understand what you want, and then you will run the calculation script accordingly for that combination, for whatever the requirement is. Because if you have this calc all done every time, believe me, it's gonna take forever.
Okay.
Okay. And then you'll have this, you will create a few calculation scripts, the default calculation script, and then you will follow the testing, which you do, I think, which you basically do most of the time. You go to the smart view and try to, test if you are getting the values correctly. Whatever the load was done, are the values being displayed out, I mean, accordingly? Is there any difference in the values? So this is testing. Okay. Did you want me to wait here, or do you want me to continue?
We can go on for another 15 minutes.
Okay. Now testing, there is an explanation again here. Whatever we talk, by default, intelligent calculation is enabled, and Essbase calculates only data that changed since the last calculation. If your outline hierarchy has errors, you may need to perform multiple iterations of your calculation test to ensure correct test results for each iteration. So you may need to disable the intelligent calculation. That's what he's saying. Since you want to test the data, with uh, and they might have errors, and you don't want the cal call to happen over and over again. So that's why you turn it off and then run it whenever you load the data, whenever you want. That's the control will be yours, not the Essbase's control. So they also say that the default calculation is calc all. That means it will perform a calculation for all the combinations or all the data, basically.
Okay.
When I say calc all, it happens on the whole database, not a slice.
Okay.
So how you test is basically you clear all the data because you don't want anything from the history. It may have errors. So you clear all the data, then you load the test data. You will run your calculation script, whatever it is, and then you will audit your calculation results. That's how you do it. Now this happens every time there is a requirement. Every time you do it on the development servers. This is the activity which you do on every requirement. This is called unit testing. And then there is UAT. Once you get,
yeah, familiar with those stuff. We do all that system testing, unit testing, UAT, and all.
Yeah. So here it explains, only data blocks marked as changed or recalculated. That's when you will have this intelligent calculation on.
Right.
And on the calcol, obviously. Okay, I don't want to get in here. Summary, okay, this is what we learned. Describe data descriptor dimensions, design, time, scenario, and accounts dimension. We learned about accounts. We didn't learn about time because I didn't want it to. Scenario, yes, we worked on it. So scenario and accounts is done, time is left out. Explain outline calculations, that's done. Test outline calculations is also done. So pretty much done. Okay, period to date totals. This is very important. This is where MTD and everything else comes into picture. YTD, MTD, and everything else. Okay, so let's start with aliases. What are aliases?
These are the friendly names.
Absolutely. These are just the nicknames.
Right.
These are used as reporting names, used for name mapping. So, I mean, basically why you need aliases is Essbase has a few limitations over the member names. It cannot be very long enough, and then you don't want it very long enough. Basically, you will follow a nomenclature.
Right. I think it's 80 characters, right? Because we had the same problem one of our Essbase cubes where I think it said 80 characters or something.
Yeah, 80 characters. Yeah, and then the designers, they would like to follow a particular nomenclature. Okay, so let's say the guy on the top is 1. They use 2s for the siblings, and then the children will have 2A, 2B, 2C towards the end, that's to understand the levels basically.
Okay.
Once I look at a member name in a calculation script, I should be able to understand if it is a level 0 member or a level 1 member. That's the nomenclature which we follow. As soon as you see the name of a member, you should be able to say, okay, this is at level 0.
Right.
That's how we design the member names. Especially for accounts. And then for the entity dimension, okay? And the products,
right.
Okay? So that's why it's hard to tell. I'm sorry. It's hard to understand looking at someone looking at the names, they are hard to understand. And if you want a user-friendly name, you just add an alias to it.
Right.
Okay, now here are the challenges. So aliases are reporting names used for name mapping, updated in member properties. So you'll have an option in member property for alias. They are stored in aliases tables. Okay. Now aliases tables are created in outline properties. Okay. And then they are limited to 32 for database. So you can have about 32 tables for your aliases. That's the maximum. We don't run out of it, so that's okay. Did it show the steps? Here it shows the steps, how to create an alias table.
Right.
We'll go through that later. This is the practical part. Yeah, these are the dimension types. None is by default. It's when you create an outline without anything, without declaring it as an account or time, then it's a default one. And the country is basically the region. Okay. Currency is a currency table if you have the currency conversion involved in your application. If your application is multi-currency, that's when the currency comes into picture. Okay. Otherwise, what happens is they basically, initially when they are starting the whole application, they will set the base currency. It could be US, it could be US dollar or pounds or whatever it is. Okay. And then if you declare an attribute, a dimension as attribute, then it will become an attribute dimension. So these are the types of dimensions. We can go through that. Now this is important. We'll discuss this tomorrow. Calculated members. QTD, YTD, I think you should be aware of all this.
Right.
Yeah. We'll just go through it tomorrow. I think this is all we have for this chapter. The fourth. Okay, I have the dynamic calcs and the stores. This is time balance, TB first, TB loss, TB average. Do you know how this works?
I don't think so.
Yeah, it's basically used in inventory.
Oh, okay. The first in, first
Yeah.
out?
Yeah, so time balance first, time balance last,
Okay.
and then time balance average. So opening inventory is time balance first, and then the closing inventory is TB last.
Mm-hmm.
And then if you want an average, then you use the TB average. So if you have Jan, Feb, and March, so TB first. If you tag the opening inventory as TB first, okay, it will pick the first value, which was 20. So this is the opening balance, right? Opening inventory. That's how you open your quarter. That's the number you open your quarter with that in the inventory. Now, if you are tagging the ending inventory TB last, that means it will pick the value which is stored in March.
Mm-hmm.
Because this is the closing inventory.
Oh, okay.
Yeah, so that's how it will pick.
Right.
Yeah,
So
that's TB first and TB last.
Right.
That's very, very important interview point of question.
Oh, okay.
Yeah,
So
I think. Yeah, sorry, go ahead.
some MDX scripts too, or
MDX, no, I am not really good at it.
oh, okay.
But
Like
yes, we can figure it out. We can figure it out. I mean, if you really want to learn, then yes, we can sit down and learn.
Okay.
It would be a learning for both.
Okay.
I will
Okay,
a
just
lot.
like a very basic query, like a
Yeah.
like a select from all this kind of thing.
Yeah, select thing. Yeah, select is done. There is a little difference between the RDBMS queries and the MDX queries.
Now, in the S-based bootcamp, right? Do they cover MDX queries also, or no?
I think they do. I think they do because
it's a class like MDX scripting and all.
I think they do. I think so because it's one of the important. How do I say? It's one of the important ways to load the data.
Okay.
Yeah. And yeah, I think they do. We'll figure that out. I mean, it just takes one more class, right? That's okay.
Sure.
But you can note that down. We will cover that up.
Okay.
I'll try to find some source and then we can work it out.
Okay, good, very good.
No problem. I'm just trying
And
to.
I'm also thinking, Mohammed, maybe I'll just continue planning with you itself. I don't want to, switch to another
Switch
person.
the tutors.
Hmm?
You will like him. Don't worry. He's
Okay.
very good. He's very good. He's very good. You will like him. I mean, it's completely up to you, right? You can go with the demonstration and then you.
Okay.
There is no insistence, right? But I mean, for me to choose the best for you, I think is a good choice for you as well. Yeah, you can just listen and you go for a demo and understand how he puts everything out. So it's completely up to you. The final call is yours.
Sure.
I'm just being a little more concerned. That's all.
Sure.
I think I'll have to sit down definitely on this because I need to have this sorted out.
Mm-hmm.
So the next chapter is this, definitely the fourth one. We will go through the whole fourth chapter. Very important. This is very important.
Okay.
It has some beautiful topics.
Right. And a little bit of sense of this. I think.
Yeah, I mean, you need this. This is very important. YTD concepts, the QDD, the MTD concepts, very important. And then the time balance reporting is very important,
Right.
especially for the functional part, which
Right.
you are into basically, which you want to understand. So let's say the customer is, talking all these terms, you should be able to understand, okay, and then you will be able to give a solution out to him as well.
Right.
So, I mean, this is very important.
Right.
Let's look at it from tomorrow. The 4th chapter, we will finish it in 2 classes or maybe 1. If you are able to catch it up quickly, 1 class should be good.
Sure.
Okay, so
All right.
I'll let you go now.
Yeah, tomorrow evening.
And then we will catch up tomorrow.
Thank you.
Sure, no problem. Pleasure was mine. You have a very good day. I mean, good night. Sorry.
Yeah. Thank you. Bye.
Sleep well. Bye.